In this video, I want to demonstrate how to use sequential if structures to find the highest or lowest value of a list of values. In this case, we have 5 runners in a race, and we have their name as runner 1, runner 2, runner 3, and their times as time 1, time 2, and time 3. I want to create an algorithm that will go through all 5 of these runners and figure out who had the fastest time, which would be the lowest time. So we're going to assume if we had just one runner, if Angel was our only runner and Angel's time was 35.62, that would be the fastest time. So we're going to start there. We're going to create a variable called fastest and set it equal to time 1. And we'll say the fastest runner was runner 1. Now we're going to add a second runner in, and that's going to be Billy. Billy had a time of 32.09. So we're going to ask the question, is Billy's time, time 2, less than fastest? And if it is, we're going to swap fastest with the value of time 2. And we're going to set fastest runner then equal to runner 2. If Billy's not faster than Angel, then fastest and fastest runner remain Angel and Angel's time. Then we'll check runner 3. Is runner 3 less than the fastest? It doesn't matter at this point if fastest was runner 1 or runner 2. We're just comparing to which one was the fastest and is time 3 less. If it is, we'll set fastest at time 3, and then fastest runner will equal runner 3. Next, we check runner 4. Is runner 4 time less than fastest? If it is, we set fastest equal to time 4 and fastest runner equal to runner 4. If not, we retain the values of fastest and fastest runner. And then finally, we check runner 5. Is the time 5 less than fastest? It doesn't matter whether the fastest is 1, 2, or 3, or 4. If runner 5 is less, then the fastest time becomes time 5 and the fastest runner becomes runner 5. At that point, we have figured out who the fastest runner is, and all we need to do is output the result. So looking at our values here, we would say the fastest runner was Chris at 31.42. Well, let's run and see if that's what this finds. So it indeed does tell us that Chris won the race with the fastest time of 31.42, and I actually have the race in there twice, so I'm going to come back here and fix that. Run the race with the fastest time. Let's try this again, but I'm going to change some values here. Let's set Danny to 30.72, which would make Danny the fastest runner. Let's run. We're going to save. And now we're told that Danny won the race with the fastest time at 30.72. Well, let's make EJ just a little bit faster. EJ will be 30.11. We're going to test again, and this time it tells us EJ won the race with the fastest time of 30.11. If we make Angel the fastest, we're told that Angel won the race with the fastest time at 29.62, and then let's conclude by having Billy win the next race at 29. Let's just go 6.1. 100th of a second faster. We're going to run the module, say OK, we're going to save it, run it. Billy run the race with the fastest time at 29.61. So the algorithm works for all 5 times. We could do the same thing to find the slowest time. Just rather than using less than, we'd use greater than, and have to have a slowest and a slowest runner.